Hello everyone, thanks for watching. Today I'm going to go over my newest quant finance project, which is a way to model how forward swaps behave whenever there is a yield curve shock. So we're not looking at just one specific yield change, but a change on the entire curve. So what's the purpose of this project? The purpose is whenever an institution is in a forward rate swap or a forward swap, this can be at times a bet on the yield curve. So what is the best shock model to make? It's going to be a shock model looking at changes in the yield curve. Because specifically, if you have a portfolio heavy in forward swaps, you're going to want to be able to model how different scenarios, sometimes extreme unpredicted scenarios, could change the projected coupons in those swaps and how you would survive a mark-to-market on that. So first of all, I'm going to go over all the specific sections of this project, and then I'm going to talk about the outputs. So for our input table, it's really simple. We're just going to put in, we're doing years 1 through 10 here, and we put in the spot zero rate, and then we put in the shock. So we don't put in the final destination of the shock, we just say how much. So as you can see, we have a forwarded curve right here, just going up 10 basis points. And then I'm just using a simple example here for the student project. And for the shock, we're going to do a bear steepener. So the ones are going to experience about 10 basis points, 2s 20, 3s 30. You can see where I'm going with this. And with our outputs, we put in our new zero rate. So our new zero after that shock's going to be like 4.1 for the ones, all the way to 5.9 for the 10s, or 5.9%, because we're using decimals. We put in the discount factor for the spots. Then we put the discount factors for the shocks. And this just shows the change in discount factors. So as you can see, as one would expect, when zero rates are shocked upwards on a steepener, you see discount factors decreasing from that event because that's just the discount math. As you can see, that Euler negative rate time formula. And for here, the example, I'm making a ones table just because it was a quick, convenient one. So this is like, here would be ones, but we're looking at the far year. So this is 1 to 2, 1 to 10. We look at our, we're looking at the forward rate, so not the swap rate. So that's just the ln over time one. So that's an annualized. So this is our forward rates at the spot. This is our post-shock forward rates. And as you can see, forward rates are going up alongside with the yield curve bear steepener. Here we have our change, so you can see the change. So what's interesting is whenever we shock the 10s by about 100 basis points, but the ones by 10 basis points, that 1 to 10 for the forward rate is going to be 110 basis points. It's a pretty linear, easy to follow example. It gets a bit more difficult when we get into that swap rate, because as you can see in the formula, it is your near year on minus far year over the sum of all the coupon payment years within it. So the discount factors we're speaking about. So this is our swap rate at the spot curve. This is our swap rate at the shocked curve. And we can look at the change here. So what's interesting is you see the swap rate for the 1s to 10s is 0.0106, while it's 0.011, so it's actually less than the just forward rate. And the charts are going to get into that with the models. This is our swap rate minus rate basis, so we look at the spot and then we look at the shock, and then we can model the change, so the change in that basis as well, because the swap rate minus rate basis is also going to change when there's a yield curve shock. So it gets really complicated fast. So in my last swaps video where I introduced the concepts of forward swaps, it was just that really simple, looking at the formulas, how would you model it, how would charts of it look like. This is where the swaps start to get messy. When there's a shock, there's so many variables, and this is just a student introductory, but I could get further out into it. Here I'm going to look at our output tables, and this is visual because this is a more advanced topic for me. Like I needed visuals to understand it, and basically what we're going to look at here is our spot versus shocked zero curve. So you can see there's our spot curve, there's our spot zero curve after a bear steepener shock example. Here's our spot versus shock discount. So as you can see, as expected, when we run a bear steepener, the discounts decrease out in time as well. And then this is the charts that explain the nuance. So this is the shock change. So this is the changes here in the forward rate versus the change here of the swap rates. So as you can see, closer till about around year 7, that's when we hit the neutral, when they converge. But for those first 7 years, it's actually the change in the swap rate is more than the change in the just forward rate. But after year 7, we actually have a situation where just the forward rate is the change in the forward rate is more than the change in the swap rate. It actually makes almost similar to conceptually the convexity curve, but totally different reasonings here. And this one shows the swap rate minus rate basis of the spot curve versus the shocked after a bear steepener curve. So this is in orange are spot curves. So with that kind of forwarded normal looking curve, this is how it looks. But after a bear steepener, you see year 7's that important example. The basis is much higher for the shocked, but out in time, kind of as we're looking here, that basis significantly decreases. Now, the important concept to learn from here is that there is a nonlinear way that the swap rates move on yield curve changes. So even if you have a linear bear steepener example in our shock of the yield curve, there's a very non-linear change in the swap rates. You can see the changes. So this is where math gets messy, and quantitative work has to be more precise, more variables, more degrees of accuracy, because when you are trading the curve via swaps, forward swaps, you're going to see some very non-linear action and some very quick action, and unless it's hedged and thought of advanced or even just structurally neutralized at the beginning of the trade, you can see some mark-to-market action that would not be clean if you are wrong on your thesis. Anyways, thanks for listening. I'm glad y'all check this out, and I'm continuing my series on swaps modeling and the nuances of fixed income swaps. Have a great rest of y'all's day.